You will be able to determine the ionization of main group elements and some transition metals. An ion forms when an atom gains or loses an electron. Ions can have a positive charge or a negative charge. Now, before we delve deeper into ions, let's review quickly about valence electrons. Valence electrons are the electrons in the outermost energy level of an atom. They are the only electrons involved in chemical bonding, and they determine the chemical properties of an atom. Let's look at some examples. In these three Bohr models, the valence electrons are the darker colored circles. Boron has 3 valence electrons. Silicon has 4 valence electrons. And finally, antimony has 5 valence electrons, 5 electrons in its outermost shell. But we don't need Bohr models to look at the number of valence electrons. We can just use the periodic table. We can find the number of valence electrons in an element by looking at its group number. Group 1 elements, also known as the alkali metals, have 1 valence electron. Group 2 elements have 2 valence electrons. Group 3 elements have 3 valence electrons, and so on and so forth up until group 8. Now group 8, the noble gases, all of those elements have 8 valence electrons, with one exception, helium, which only has 2. Now that we've reviewed valence electrons, let's go over the octet rule. An octet is merely a set of 8. Now the octet rule states that atoms with a full octet of 8 valence electrons in their outermost shell are the most stable. This is why the noble gases are the most stable elements on all the periodic table, because they have a full octet in their outermost shell. No more electrons can get in there for them to react. Let's take a closer look at these noble gases. This is the Bohr model of neon. Neon has 8 valence electrons, that is 8 electrons in its outermost shell. And as you can see, all the other noble gases, they also have the same number of electrons in their outermost shell, making them very stable, making them unreactive. Argon, another noble gas, 8 valence electrons. Look at krypton. Count the outermost electrons. There are 8 valence electrons. And the pattern holds with xenon and radon. There is one exception, and that is helium. See, helium only has 2 electrons. However, it's still extremely stable because the first energy level of the helium atom can only hold 2. So no more atoms can come on, no more electrons can come on to that first energy level to make helium react. What makes these noble gases unique is that they all have 8 valence electrons, a full octet, which makes them the most stable out of all the elements. When other neutral atoms gain or lose electrons, they tend to do so in a way that gives them a total of 8 valence electrons. This is important when it comes to ions. That's why I spent so much time reviewing noble gases and valence electrons and octets. Other elements, other atoms gain and lose electrons in such a way where they come to their most stable form. That stable form being having 8 electrons in their outermost shell. Ionization is when a neutral atom becomes an ion by losing or gaining electrons. An atom that becomes an ion has been ionized. When atoms become ionized, they lose or gain electrons in such a way that they are left with a full octet, 8 valence electrons. Let's take a look what happens when sodium is ionized. Look at the periodic table, it has an atomic number of 11. Therefore, the neutral sodium atom will have 11 protons and 11 electrons. Look at the figure to the left. You can see that it has 1 valence electron. Now, carefully look at that figure on the left. It's going to turn into a sodium ion. You see how it changed? It has now only 10 electrons, but it has 8 electrons on its outermost shell, 8 valence electrons. So when sodium lost its outermost valence electron, it gained a full octet, which makes the sodium ion more stable. If you look on our periodic table, we see that sodium has an atomic number of 11. Therefore, a neutral sodium atom has 11 protons and it has 11 electrons. Now, the protons are positively charged and the electrons are negatively charged. Each positive charge cancels out a negative charge, like so, leaving the neutral sodium atom with an overall charge of 0. Now, the sodium ion, on the other hand, still has 11 protons, but since it has lost an electron, it only has 10 electrons. So, when we look at how the charges cancel, positive still cancels out negative, but what happens is we still have a positive left over, giving the sodium ion a charge of +1. Thus, the symbol for the sodium ion is Na+. Another example, calcium. A neutral calcium atom has 20 electrons, and it has 2 valence electrons on its outermost shell. Now, watch the figure on the left carefully. It's going to turn into a calcium ion, which has 18 electrons and 8 valence electrons on its outermost shell, giving it a full octet and making it more stable. If we find calcium on the periodic table, it has an atomic number of 20, so it has 20 protons. And since it's neutral, we know that it has 20 electrons. And the 20 positive protons and 20 negative electrons cancel each other out, giving us an overall net charge of 0. Now, the calcium ion lost its 2 outermost electrons, so even though it still has 20 protons, it only has 18 electrons. And what happens is, when the positive charges cancel out the negative charges, we have some extra positive charges left over. So here we have 2 positive charges left over. So it has a charge of +2. So when we write the symbol for the calcium ion, it's Ca2+. When atoms lose electrons, become ions, they are called cations. Atoms of metals tend to lose their valence electrons, and cations are positively charged ions. Anions, on the other hand, are negatively charged ions, and you get an anion when an atom gains an electron to become negatively charged. Nonmetals typically gain electrons to become negatively charged and are called anions. Let's take chlorine. Atomic number 17. So the neutral chlorine atom has 17 protons and 17 electrons. And as you can see on the figure to the left, it has 7 valence electrons. But carefully look at that figure. It's going to ionize. It's going to gain an electron, giving it 18 electrons, but more importantly, it's going to give it 8 valence electrons. Therefore, chlorine ion will have a full octet, which is more stable. Now, neutral chlorine atom has 17 protons and 17 electrons. And as usual, the positive charges and the negative charges cancel each other out, so that there is no net charge, a net charge of 0. Now, the chlorine ion still has 17 protons, but it has 18 electrons. So when we go to cancel out the charges, each positive proton cancels out a negative electron. Eventually what happens is we're left over with a negative charge. So we have an overall charge of -1. Therefore, we write the chlorine ion as Cl-. Now we'll look at the ionization of phosphorus, atomic number 15, 15 protons, and 15 electrons. The outermost shell has 5 valence electrons. Now look at the figure. It is going to turn into a phosphorus ion, gaining electrons. So now it will have 18 electrons, but more importantly, it will have 8 valence electrons on its outermost shell, which is a full octet. Now, a neutral phosphorus atom has 15 protons and 15 electrons. And as usual, the positive and negative charges of the protons and electrons cancel each other out. Now, the phosphorus ion has 15 protons, but it has gained 3 electrons, so it has 18 electrons. So, when the positive and negative charges cancel out, it leaves us with 3 extra negative charges. So it has an overall charge of -3. Therefore, we write the phosphorus ion symbol as P3-. There's a clear pattern to which elements ionize and their charges that they gain, and we can look at that pattern and see it by just looking at the periodic table. The elements in group 1, they lose an electron in order to gain their full octet, giving them a charge of +1. In group 2, they lose 2 electrons to get their octet, giving them a charge of +2. And in group 3A, they lose 3 electrons, giving them a charge of +3. Now we look over on the other side of the periodic table at the nonmetals, and we look at the halogens, group 7A. They gain an electron in order to gain their full octet, giving them a charge of -1. And group 6A, which includes oxygen and sulfur, they will gain 2 electrons in order to get their full octet, and they have a charge of -2. And finally, group 5A, which includes nitrogen, phosphorus, and arsenic, they will gain 3 electrons in order to get their full octet, giving them a charge of -3. Well, what about group 4A, which includes carbon and silicon? Well, these elements form mainly covalent bonds, not ionic bonds. The main group elements, they follow a set pattern. Whatever the group number is, that's the number of valence electrons, and you can easily predict its charge of the ion that it forms. However, transition metals, they often form multiple ions. They're a little bit more complicated. For example, titanium is sometimes have a charge of +1, but also +2. Chromium has +2 and +3. Iron has +2 and +3. Cobalt +2 and +3. Nickel has a +2. Copper +1 and +2. Zinc +2. Silver +1, platinum +2 and +4, gold +1 and +3, and finally mercury +2.